Humans have always wondered what constitutes the Earth's interior. In the geography syllabus, we have a subtopic called geomorphology, within which we need to study regarding the Earth's interior. So in this session, we'll be discussing regarding the interior of Earth. We all know that Earth is in geoidal shape, and we calculate the Earth's average radius to be somewhere around 6,400 kilometers. 6,400 kilometers means from the Earth's center towards the surface of Earth, the distance is 6,400 kilometers. So how do we get information regarding these 6,400 kilometers of depth? The deepest hole or the deepest man-made hole ever made was in Russia. That is around 12 kilometers depth. So 12 kilometers is very less when compared to the 6,400 kilometers. So there are several sources that provides us information regarding Earth's interior. We can classify these sources into two. We can classify them into direct sources and indirect sources. So sources of info regarding Earth's interior, we can classify it into two. We have direct sources and we have indirect sources. If the source that is providing us the information regarding the Earth's interior, we get something physically from the Earth's interior, we include them in direct sources. On the other hand, it's not a physical object. We are based on some other values. If we are assuming things regarding Earth's interior, we call them as indirect sources. When I say the examples for direct and indirect sources, you will get a clear-cut idea. So direct sources, as I told, we get something physically from the Earth's interior. The best thing we can say, when we are having mining, we mine to get minerals, isn't it? So during mining, we go deep into the Earth's interior. We get different rock particles from the Earth's interior. So when we study about these rock particles, it provides us information regarding how the Earth's interior is composed of. So we can say the rocks from mining areas, rocks from mines. Secondly, another important thing that comes from the Earth's interior naturally is during the volcanic eruption. We know that during volcanic eruption, magma comes out, gases comes out. So through volcanic outputs, when we study these volcanic outputs which are coming from the Earth's interior, that also provides us information regarding Earth's interior, and they belong to the direct sources. If we move to the indirect sources, we can say one of the indirect source of Earth's interior, information of Earth's interior is the changes in temperature and pressure. Changes in temperature and pressure when we move deep into the Earth's interior. When we are moving deep in the mines, there will be change in temperature. So we see for the first 5 kilometers, there was 100 degrees Celsius temperature. I'm just hypothetically, I'm saying some values. If for the first 5 kilometers, there is 100 degrees Celsius difference. So how will be the next 5 degrees Celsius? So we can calculate all these. So we study the change in patterns of the temperature and pressure, and we assume things based on that. So that is an indirect source. Another indirect source is the seismic waves. Seismic waves means the waves which are generated during an earthquake. When we study about these waves which are coming from the Earth's interior, that also provides us information. We can also say the gravity or the gravitational force. For example, we know, like the basic science, we know the formula for gravity. The force is equal to Gmm by r square, where G is the gravitational constant, capital M is the mass of Earth, small m is the mass of object, and r is the radius of Earth. So where the radius is high, the gravitational force will be less. So that's why we are having less gravitational force in the equator compared to the poles. So we at least know that the polar region, the radius is less compared to the equator. So gravity is another source. We have another sources like meteors. Meteors means these are the parts of other celestial bodies. We believe that these things are made of the Big Bang theory, from the Big Bang. So the formation is almost same. The process is almost same. So we consider that the interior of these particles or the celestial bodies and Earth is almost similar. So we conduct some study on these and we assume things, or we come into conclusion regarding how the Earth's interior is. So these are the different sources of information, direct and indirect. So for our civil service exam, we need to study some details regarding Earth's interior. So I will try to conclude those things in a single figure. If you study this single figure, you will have a general idea regarding the Earth's interior. So I will explain this figure. So listen. So I'm taking a sector out of the Earth's interior. Okay, I'm drawing a sector out of the Earth's interior. So this is the center, this is the surface. From our school days, we have studied that Earth interior can be classified into three. We can classify it into crust, mantle, and core. You must be knowing the topmost portion is the crust, the innermost portion is the core, and the middle portion is mantle. You must be knowing that. So I'm dividing the Earth's interior into three. We have the crust, we have the mantle, and core. I'm not writing this. This is known by every school kid. Okay. So I'm again dividing the crust, mantle, and core. I'm again dividing it. Okay. So I'm dividing the crust into two, mantle into two, and the core into two. This portion is called as the upper crust. Okay. The upper portion of the crust, upper crust. Lower portion of the crust, lower crust. Upper portion of mantle, upper mantle. Lower portion of the mantle, lower mantle. Upper portion of the core, we call it as the outer core. Inner portion of the core, we call as the inner core. So we divided it into crust, mantle, and core. Crust again divided into upper crust, lower crust. Mantle divided into upper mantle, lower mantle. Core divided into outer core and inner core. So when we have a volcanic eruption, we know that the molten rocks, the lava comes out from the Earth's interior. So from which of these parts? Is it from the crust, mantle, or core? The lava is coming out. We usually think that the core is the region where we have this boiling molten rocks present. But please do understand, within the region of upper mantle, okay, over here, within the region of upper mantle, we have a semi-solid layer. Okay, within the region of upper mantle, we have a semi-solid layer. The semi-solid layer means it's basically made of the molten rocks and molten soil. This molten condition is due to the high temperature present over this region due to the Earth's radioactivity. This semi-solid layer within the upper crust, sorry, upper mantle, this region is known as the asthenosphere. Okay, so within the Earth's interior, in the upper mantle, we have a semi-solid layer which we call as the asthenosphere. So when we study the plate tectonic theory and all, we can say that the plate tectonic plates are floating over this asthenosphere. So just for the time being, just understand, we have a semi-solid layer in the upper mantle, we call it as asthenosphere. The region above asthenosphere, okay, the region above asthenosphere, which includes some portion of upper mantle and the remaining part of the crust. Okay, the region above asthenosphere, which contains the upper mantle and the crust, that portion is called as the lithosphere. So lithosphere consists of the crust and some part of upper mantle. The region of mantle below the asthenosphere, okay, the region over here, the mantle region below asthenosphere, we call it as the mesosphere. Okay, the region below, the mantle region below asthenosphere is called as mesosphere, and the core region is called as barysphere. So this is yet another classification of Earth's interior. So within the upper mantle, we have a semi-solid layer which we call as asthenosphere. The region of the crust above asthenosphere is called as lithosphere, and the region of the mantle below asthenosphere is called as mesosphere, and the core region is called as barysphere. Now, if you look at the crust, mantle, and core, they have some other names also. The upper portion of the crust or the upper portion of the Earth's surface is usually called as sial. The upper portion of the Earth's crust or this region is mostly called as sial. S-I-A-L. It's known as sial because this region is majorly consisting of silica and alumina. The lower portion of the crust is called as sima. Sima because it's basically made up of silica and magnesia. And the core region is commonly called as knife, N-I-F-E, knife or nife, you can pronounce it either way, because it's majorly made up of nickel and iron. Okay, so the upper portion of the crust is called as sial. The Portion below that is called as sima, and the core region is called as knife or nephe. The crust is majorly made of silica and aluminium, so hence called as sial. The below region is silica and magnesia, hence called as sima. And then we have knife, that is nickel and ferrous. Then if you look at which state, whether they are solid, liquid or gaseous, we know that the upper crust is basically in solid state. Lower crust is also in solid state. Upper mantle, solid state. But the asthenosphere, we already said, asthenosphere is in semi-solid state. Lower mantle, again solid state. Outer core, listen carefully, Earth's outer core is in liquid state and Earth's inner core is in solid state. So the crust is in solid state, asthenosphere semi-solid, the remaining portion of mantle solid, outer core liquid, inner core solid. The reason is that as we move to the Earth's interior, the temperature is increasing. In the deeper parts of Earth, the temperature is tremendously high. It's almost said that at the core region, the temperature is around 3000 to 5000 degrees Celsius. Still, the inner core is in solid state. The two major reasons that causes the inner core to be in solid state is that, firstly, this region is made up of high melting point elements such as nickel and iron. Secondly, the pressure over this region is tremendously high. Here, the pressure is applied by the objects lying above it. For example, if I am staying at 1 kilometer depth, suppose I am at 1 kilometer depth in Earth's interior, I have the weight of rocks and soils that is above me for 1 kilometer. If I am at 5 kilometer depth, means I have the weight of 5 kilometer soil and rocks above me. So as I am going deeper and deeper, the pressure over me keeps on increasing. So on the deeper part, the pressure is tremendously high, so that even at that high temperature, the inner core remains in solid state. Okay, so that's why the inner core is in solid state. In outer core, the temperature is high, but the pressure is not reaching up to the inner core, so it is almost in liquid state. Okay, we have one more data to include in this figure: crust, mantle, core. We have this classification. That means these are different layers of Earth's interior. So when we are moving deep into the Earth's interior, these layers will be non-continuous in nature. That means there will be change in the rock structure, there might be change in temperature, there might be change in the color, there will be many changes. So they are not continuous in nature. So we call these boundaries usually as discontinuities. We call them as discontinuities. The discontinuity between upper crust and lower crust, we call them as Conrad discontinuity. Upper crust, lower crust, we call it as the Conrad discontinuity. Between lower crust and upper mantle, or between crust and mantle, we call it as the Mohorovic discontinuity. Between upper mantle and lower mantle, we have Repethy discontinuity. Lower mantle and outer core, Gutenberg discontinuity. And outer core and inner core, we have the Lehmann discontinuity. So discontinuities are basically acting as the boundaries between upper crust, lower crust, Conrad, lower crust, upper mantle, Mohorovic, upper mantle, lower mantle, Repethy, lower mantle, outer core, Gutenberg, outer core, inner core, Lehmann. These names are important, can be asked as match the following for the exams. Okay, so these much information you must have regarding Earth's interior. There are still more, but this is the basic thing you should be knowing. Okay, so what we did, we basically classified the Earth into crust, mantle and core. Crust we divide into upper crust, lower crust. Mantle we classify into upper mantle, lower mantle. Core we classify to outer core, inner core. Then in the upper mantle we have the semi-solid layer called as asthenosphere. The region above asthenosphere we call it as lithosphere. The region of mantle below asthenosphere we call it as mesosphere. The core region we call as barysphere. We know that the crust is in solid state, asthenosphere semi-solid, remaining portion of mantle solid state, outer core liquid, inner core solid. Then crust, the upper region known as sial, because majorly made of silica and alumina. Below that we have sima, that is silica and magnesia, and the core region called as knife or nephe, because it's majorly made up of nickel and iron. Then we have discontinuities between these layers. Between upper crust, lower crust, we have Conrad discontinuity. Between lower mantle, upper mantle, or between lower crust and upper mantle, or between crust and mantle, we have Mohorovic discontinuity. Mantle, upper mantle, lower mantle, we have Repathy. Lower mantle, outer core, or between mantle and core, we have Gutenberg. Between outer core, inner core, we have Lehmann. Along with that, we also need to notice regarding the like the depth or the dimension of this crust, mantle, core region. If you look at the crust region, the crust, okay, we can say the depth, the average depth of the crust region from the surface, we can say the depth of the crust region to be somewhere around 8 to 40 kilometers. Okay, the thickness of the crust is around 8 to 40 kilometers. Because when we study the plate tectonics, we will study in detail. The continental crust are thicker, oceanic crust are thinner. For example, you consider a point in Indian Ocean, you consider Mount Everest. Mount Everest, which is thicker, it is higher, isn't it? On the other hand, when we go into the oceanic part, the crust is thinner. So it varies from 8 to 40 kilometers. Then if you look at the mantle region, the thickness is around 2,900 kilometers. So the remaining region, around 3,400 is the thickness of the core region. So these are some basic idea regarding the Earth's interior. Hope you got an idea regarding the Earth's interior. Hope this session was fruitful. Thank you everyone. Thank you.